Given two strings s and t, return true if s is a subsequence of t or false otherwise. A subsequence of a string is a new string formed from the original string by deleting some can be none of the characters without disturbing the relative positions of the remaining characters, i.e. ACE is a subsequence of ABCDE while AEC is not. So I know this one because I've done a more complicated problem that basically required you to find the longest subsequence. So I do. Let's see. So let's see if I can do this fast. So we do have the two pointer solution, which is iterate through t if that character is the current pointer of s, return if the character is a current pointer of s, increment that pointer if that pointer exceeds the length of s, then it's true. So it's like that. So we could do that, but I actually think that we can do better. Why don't we do the first solution first? So we'll just have say for c in t if and we'll have an s pointer that starts at 0 if c equals s pointer, then as pointer you increment that, and then if s pointer, again hold on to that in the variable, n equals length of s, if s pointer now equals n, if s is a pointer to n, if it's now iterated through the whole thing, return true, and if you make it through the entire thing, return false. So we also need to add the edge cases of when there's 0. So we're going to say if s equals 0, return true, because subsequence of if length of s equals 0, then it's got to be true, because a empty subsequence will always be a subsequence of something. If it's greater than 0, then if we get to this point, that means s is greater than sub 0. So we'll also just is the length of s is greater than 0. So that means that if t equals 0, we return false, because you can't possibly have gone through the entire thing. We could just also say, I think we could just minimize this and just say if we could say, or sorry, if the length of t is equal to 0. We could also say if the length of t is greater than n, is less than n, then you return false, because you can't possibly fit a subsequence into a sequence that's smaller than that. So we just run that. It accepts it. I think we can do faster though. So this is gonna be like 50%. Okay, so that's okay. I think we can do even better though. But the problem is it might take up more memory. Why don't we just say, okay, well, let's reset this. Here's the other solution. You can say letter appearances equals an empty map, and then we're going to go through for c in t, for I in range t, because we want the indices now, in range length of t. I always mix that up. Um, now we're just going to say C equals TI. If C in letter appearances, then we're going to say letter appearances C plus equals 1. Otherwise, we're going to say letter appearances C equals 1. So now we have a bunch of, well, all of the letters in the string T and all of the appearances of that. And now what we can do is we can say active index equals 0 or equals -1. And what we're going to do is go through letters in S, and we're going to what is it? We're going to go through all the active letters in S, and set the value of active index to, for every letter, the minimum value in the minimum index in the appearances that's greater than the active index. So, for example, if we have like A, M, 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 B, M, C, let's say we had C, A, and we were looking for A, B, C. So basically what this does is it allows us to skip over all the letters. Now, to be honest, I actually am now realizing that this isn't going to be any faster because you still got to iterate through the entire array. Well, still got to iterate through both strings in their entirety. So you might as well iterate through, well, you're going to do the same thing. So you might as well save some space and not have a dictionary. So I hope you see what I'm saying. You have an active index, and that's -1. So we're looking at ABC, and we're looking for the first index of C. So we access the letter appearance as A, and we see, okay, so A appears at 1. So now the active index is 1. So now we look for B, and we see that appears at 7 or 5. So now we set the active index to 5. And then finally, when we look at C, we see that C is at 0 and the last one. So so 0 has to be since 0 is less than the active index, that means we would have to go backwards. So it could be out of order. So we had to go to the next one, which is this one. And then so we get those 3 indices. And since we found all those values, since we managed to do that whole thing for all the letters, we can return true. It will return false if you ever check a letter in the map and find that it's either not in the map, or it or the active index is greater than all of the all the indices in that array, meaning that you've already moved past all the appearances of that letter. But now that I think about it, that's actually not going to be any faster. So I'm just going to stop right there.